Hello students, welcome back to Brilliant online classes. Today we are going to discuss one of the very important topic from the chapter triangle. The topic is Pythagoras theorem. Here we are discussing the definition of the Pythagoras theorem, the statement and proof of the Pythagoras theorem. This is one of the very important topic from the chapter triangle. Now let's see how it is happening. Pythagoras theorem, the statement. In a right triangle, the square of hypotenuse is equal to sum of the squares of other two sides. In a right triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. It's very obviously you can understand that the Pythagoras theorem states on a right angle triangle. Let's see, here there is a triangle ABC, right angle at B. So we already know that in a triangle, especially in a right triangle, which side will be hypotenuse? We already know that. Here we can see that angle B is right angle at B. The side opposite to the right angle will be the hypotenuse. So here the hypotenuse is AC. And the other two sides are BC and AB. So according to the Pythagoras theorem, we can state that here in ABC, we can say that hypotenuse square, that is AC square will be equal to AB square plus BC square. Here the hypotenuse is AC and AB and BC are the two sides of the triangle ABC. This is what is the Pythagoras theorem states. Once again, in a right triangle, the square of the hypotenuse is AC square is equal to sum of the squares of other two sides, AB square plus BC square. AB and BC are the other two sides. This is very simple definition now. Now we have to prove it. Let's see how it is proving. Yes, now we are going to prove the Pythagoras theorem. Let's see. Here we have the theorem, in a right triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. Okay, now we know that in a geometrical proof there are some procedures. Step by step insertion is there. So first, what is the first one? We have to start with the given things. Secondly, we have to write what you have to prove, what you have to find. That is the second thing. Then after, if there is any construction is there, that should be mentioned. Then after only we have to do the proof. This is the formal steps of a geometrical proof or geometrical question. Do you remember? Okay, now we can do the same method itself. We can start. Now first of all, we have the diagram. We have to draw one right triangle. Let ABC, triangle ABC is a right triangle at A. We have to start, we can start with the procedure. First of all, given things. Given, here it is given that in triangle ABC is a right triangle, that is right angle at B. Sorry, right angle at A. Right angle at A. Angle A is equal to 90 degree. This is what is given. The next step, what you have to prove? To prove, here we know that the side opposite to the 90 degree, this is the 90 degree right angle, the side opposite is BC. That is what is called the hypotenuse of the triangle. That already we know that. So here we have to prove that hypotenuse square, that is BC square, is equal to sum of the squares of other two sides. We have other two sides are AB and AC. Its square. So what we can, how we can write? To prove ABC square is equal to, BC is the hypotenuse, BC square is equal to AB square plus AC square. That is what is we have to prove. This is what is we have to prove. This is what is the Pythagoras theorem. Okay, for that we have a construction. Next step is given to prove. Next one is construction. We have a construction. Construction is like this. We have to draw a perpendicular. We have to draw a perpendicular from A, that we can mark it as D. That is, AD is perpendicular to BC. That is what is the construction. So next statement for the construction is draw AD perpendicular to BC. This is our construction. Got it? So first 3 steps of the geometrical proof is over, given to prove, and then after construction. Now we are going to prove. How to prove? Do you remember in our chapter so far what we were discussing? In this chapter, triangle chapter, we were discussing similarity criteria, similarity, how to prove two triangles are similar and all, right? So here that only we are following. We are proving that some triangle, we can see that here one triangle ABD, one triangle ACD, and outer one triangle ABC. We are taking some particular triangle and we are proving the similarity. Let's see what is happening. For that, we can start the proof. I am considering two triangles. Remember once again, for proving the similarity, the order of the triangle, how to choose the triangle's order, that is very, very important. So let's see what is the triangle I am choosing. I am choosing the triangles are like this. First one is this triangle and outer triangle. That two triangle I am considering. Let's see the triangles. Consider the triangle. Consider triangle. I am starting with the B. BDA. This is my first triangle. Remember what is the order I took? B starting with the vertex B through the 90 degree and ends with the A. That is the first triangle I selected. Right? So the same order I can select the outer triangle. So for that I can start with the vertex B and go through the right angle triangle and end with the next vertex. That is the order I took here. B, D is the 90 degree and next vertex. So same way I am starting with the B. What is the next 90 degree angle for the outer triangle? That is A only. So B, A, C will be my order of the first outer triangle. Are you got it? So here I can select it. Triangle BDA and triangle BAC. Okay, here if you are checking, we can see that the first vertex of the two triangle starting from the vertex B and go through the 90 degree vertex and ends the other vertex. So why I am choosing like this? It will be very easy to find out some criteria, some correspondence for proving the similarity. We know that we have to get some certain criteria for proving similarity. Here we can see that we have to find out minimum 2-3 criteria for proving. So many criteria are there: SAS, SSS, angle, or angle criteria. So many 4-5 criteria we have. So what are the criteria we can see here? Definitely from these two triangles we can see that angle B is equal to angle B. Both the triangle we can see one of the angle is common, that is the angle B. The first triangle we can see angle B is coming. The outer triangle also we can see angle B, that both are common in both the triangle. So we can take angle B is equal to angle B. The reason is it's common angle. It's common. Similarly, next criteria we can find out the vertex, the angle at D and angle at A. Both are 90 degrees because it is perpendicular. AD perpendicular means angle D, or BDA. Angle BDA is 90 degree and BAC already we said angle A is 90 degree. So we can see that angle BDA is equal to angle BAC. Both are equal to 90 degree. So we are getting one of the criteria. Two correspondents are equal. That is, both the correspondents are equal. Angles are equal. Both the angle, two angles are equal. Then we have a similarity criteria. That is nothing but AA criteria. So by using AA criteria, angle criteria, we can say that triangle BDA is similar with the triangle BAC. So we proved these two triangles, the leftmost triangle and the outer triangle are in a certain order, in a specific order. BDA and BAC are similar triangle. Then we know that if two triangles are similar, then its corresponding parts are similar. That is, all the angles will be getting equal and the sides are the same ratio that we have. So we are taking the side ratio. That is important. So by CPST, we can use the form CPST, congruent or corresponding parts of the similar triangle, CPST. We can say that we can take first two, BD, or we can take, okay, BD by corresponding side. BD means first side, BD. One of the side of the first triangle BD, corresponding side is BA. BD by BA is equal to, next I am taking DA. DA by AC. DA by AC is equal to, next one is first and last letter, BA. BA by BC. BA by BC. From this correspondence, I am selecting the first and last. These two only I am selecting for the requirement. We need only no need for all the correspondence. We are not required. We are selecting the first and last. Let's see what is happening. BD by BA is equal to BA by BC. BA by BC. If you are cross multiplying, what you are getting? If you are cross multiplying, we are getting, which implies we can say that BA square, BA into BA is equal to BC into BD. Okay. Similarly, we can consider next two pairs of triangle. Let's see, we can consider the triangles. Triangle. I am starting from this second part. This rightmost triangle I am considering. I am taking the order as CDA, starting with the vertex C and go through the 90 degree vertex D and ends on A, CDA. That is a rightmost triangle. And the outer triangle in the same order I am taking like this, and the triangle starting with the vertex C itself and going through or passing through the 90 vertex and end with the other vertex. So I can say that CAB, because in outer triangle 90 degree at A only. So I can take the triangle as triangle CAB. Again we can see some criteria, some correspondence we can find out. Here we can see that this angle C is common in both the triangles, right? So angle C is equal to angle C, that is the reason is common angle. Yes. And one more correspondence we have to find out. That is very easily we can see that this 90 degree angle in the first triangle CDA is 90 degree. In the second triangle, the outer triangle CAB is 90 degree. Both are right angles. So we can say angle CDA is equal to angle CAB. Both are equal to 90 each. Therefore, the similar criteria what we proved before the previous part. Similarly, we can say that by AA criteria, AA similarity, AA criteria, similarity criteria, triangle CDA is similar to triangle CAB. These two triangles are similar. So the same way we can say by CPST, corresponding parts of the similar triangle, we can say that angles correspondence we don't want. We have to get this side correspondence, side ratio only we have to get it. For that I am taking that CD by first two letters, two vertex indicating the CD, corresponding first two letters here it is CA. CD by CA will be equal to DA, last two letters, last two vertices, that indicates AB. DA by AB is equal to, next one is first and last vertices, that is CA by CB. So here it is CA by CB. Now the same way we can choose the first and last. I am choosing the first one and last one only I am selecting. What we will get it? That is CD by CA is equal to CA by CB. By cross multiplying we are getting, which implies CA square is equal to CB into CD. CB into CD. So we are getting two equations. I can say previously we got one equation like this. We can name it as number 1. Here we are getting one equation like this. That is number 2. BA square is equal to BC into BD and CA square is equal to CB into CD. Now what we are doing, we can add these two equations. Equation number 1 and 2. Add 1 plus 2. I am adding both the equations. Okay, now we can add. We are getting BA square. BA square, left hand side of the first equation is BA square and left hand side of the second equation is CA square. That is CA square is equal to, the right hand side of the first equation is BC into BD. BC into BD plus next equation is CB into CD. That is CB into CD. This is the second equation we added. Now see, here we can say that BA square means nothing but AB square only. BA and AB indicating the same side only. I am just changing the name as AB square. This is AB square plus similarly in same order we can say CA square means that is nothing but AC square only. So this is AC square is equal to, here you can see that here it is BC, here it is CB. Both are indicating the same side. I can take as common because these are two different terms you are adding. So I can take BC as common. BC into, what will be remains in the first term? That is BD. Plus, in the next term remains is CD. Right? So we are getting BC into BD plus CD. Okay, that is equal to, from the diagram you can see what is BD into CD. BD plus CD, sorry, BD plus CD. BD is this much and CD is this much. If you are adding these two sides, we are getting the side BC. Okay, so we are getting BC into BC, that is equal to BC square. So in short we are reaching that AB square plus AC square is equal to BC square. That is what is we have to get in our Pythagoras theorem says that AB square or BC square is equal to AB square plus AC square. We are reaching at last, we reached AB square plus AC square is equal to BC square. This is the proof of the Pythagoras theorem. Once again in short I can just explain you. First in the procedure of the geometrical proof, given, proof, construction. That is very simply we can see from the diagram itself. Then after we are choosing two triangles, different triangle, leftmost triangle and outer triangle. Here just remember what is the proper, how we are choosing, selecting the triangles. For that we are making for B, the vertex B as common and through the 90 degree vertex and end with the other vertex. So BDA corresponding BAC, starting with the B through the 90 degree, end with the other vertex. So AA criteria we are proving that two triangles are similar. Then by CPST, corresponding parts of the similar triangle, we are taking the side ratio and we are choosing the appropriate 1 and 3 because we have to get BA side. So BD by BA is equal to BA by BC. Cross multiplying we have in one of the equation. BA square is equal to BC into BD. That is the first part. Similarly, the second part we are taking the rightmost triangle and the outer triangle in a particular order. They are also very simple only. We have to choose, we have to fix C as a common vertex and through the 90 degree we are selecting the triangle as CDA. Triangle CDA and CAB. So same way by AA criteria we are getting these two triangles are similar. Then by CPST side ratio we are taking and we are considering the first and 3 same way. We are getting CA square is equal to CB into CD. That is number 2. Then after these two equations we are adding. If you are adding, we are getting the left hand side as what we require, what we have to get it. To prove what we are getting AB square plus AC square, that same thing we are getting. Then after we are taking something common, BC as common, then the bracket will become BCA BD plus CD. BD plus CD from the diagram with this, obviously it is seen that is BC only. So BC into BC we are getting BC square. So this is what is the proof of the Pythagoras theorem. So please students, practice it. Do and practice. Okay. Yes, now on the basis of Pythagoras theorem, let's discuss one problem. One of the question we can discuss it. Let's see the problem. ABC is an equilateral triangle of side 2A. Find its altitude. So here given one triangle ABC, it's an equilateral triangle. We know that equilateral triangle. Equilateral triangle is a triangle with all the sides are equal. So I am drawing one equilateral triangle ABC. Triangle ABC is an equilateral triangle. It is given that all the sides are equal to 2A. This is 2A, this is 2A, and this is 2A. We have to find its altitude. I am drawing one of the altitude. Let altitude be some AD. AD is an altitude. We know that altitude is the perpendicular to the next side BC. We have to find the length of that altitude. That is the question. Okay, we can just start the same way. Here it is given that ABC, triangle ABC is equilateral. All the sides are equal to 2A. That is equilateral means we can say that AB is equal to side AB is equal to BC is equal to AC. That will be equal to 2A. All the sides are given as the length 2A. To find, what you have to find? Here we have to find the length of AD. We have to find the length of AD. That is the question. For that, first of all, we can prove that these two triangles, first triangle and second triangle, we can prove that the two triangles are congruent. Then only we can apply the triangle, the Pythagoras theorem over ABD, because the BD length we don't have. The total length of BC only we have. So we are finding the BD length first. If you are getting the BD length BD, then from the triangle ABD we can find out the length of AD. So first of all, we are starting the proof. We are considering two triangles. Consider triangle ADB, the leftmost triangle, and triangle ADC. Two triangles we are getting. Here we can see that at side AB is equal to side AC because it is equilateral triangle. AB is equal to AC. And triangle or angle ADB is equal to angle ADC because both are 90 degree. This is sides of equilateral triangle. Sides of equilateral triangle AB is equal to AC. Here we are getting ADB is equal to ADC. Both are 90 degrees and AD is equal to AD. One of the side is common. This is the common side. So by using RHS congruency criteria, because both are 90 right triangle and hypotenuse are equal, one of the side is common side, that also equal. Now by RHS criteria, we can see that here in the first triangle ADB and ADC, both the triangle, one of the angle is 90 degree and one hypotenuse are equal and the common side, one of the side is common. Therefore by RHS congruency criteria, we can say that triangle ADB, left side triangle ADB is congruent to triangle ADC. So we are getting that these two triangles are congruent. If so, we know that by CPCT, corresponding parts of the congruent triangle, CPCT we can say that BD, last two letters, BD will be equal to CD. That is what is you have to get it. BD is equal to CD. BD, the length, the side BD will be equal to CD. We know that the length BC, the side BC is equal to 2A. And both the BD and BC are equal means what will be each side? That will be half of 2A. So this we can say BD is equal to BC, BD is equal to CD. That's equal to half of BC. That is BD is equal to half of BC means half into 2A, that is equal to A. So we are getting the side of the length of BD, that is equal to A. Now we can apply the Pythagoras theorems on the triangle ABD. ABD is a right triangle. Now we can apply the Pythagoras theorem and we can find out the length of AD. Now in triangle ABD, we know that D is the 90-degree angle and the hypotenuse will be the side opposite to 90 degree. That is AB will be the hypotenuse. By Pythagoras theorem we know that we already proved that hypotenuse square is equal to sum of squares of the sum of the other two sides. So we can say here AB square is equal to, the hypotenuse is AB square is equal to AD square plus BD square. AD square plus BD square. What is AB? AB is given 2A. So it will be 2A square is equal to 2A the whole square. AD we don't know. We don't have the measurement, that only we have to find out. Let it be there AD square only. Plus BD square. What is BD? By congruency we already proved that BD is equal to the length A. So it will be equal to A square. So transposing we are getting the length of AD, that is 2A the whole square, that will become 4A square is equal to AD square plus A square. Therefore AD square is equal to 4A square minus A square. Transposing we are getting minus A square comes to this side, become minus A square. So 4A square minus A square equal to 3A square. That is what is AD square. But the altitude is simply AD only. So AD is equal to square root of 3A square. That become square root of 3A. Simply we can say that AD is equal to root 3A. This is the length of the altitude AD. So in an equilateral triangle with the side 2A, the altitude will be root 3A. This is one of the altitude. The same way we can draw the altitude from the vertex B to from B to the side AC. That also same way we will get root 3A. And last one is from the vertex C to the side AB we can draw one of the altitude. That also the same procedure we can prove that length also will be equal to root 3A. Therefore, in this equilateral triangle with the side 2A, the length of the altitude will be equal to root 3A. Okay, I think it is clear for you. That's all the time being. Thank you. Thank you very much.